Hi guys, so today what we're going to look at is logarithms. We often call this logs for short. And we should be quite happy with our index notation that we can write, for example, that 2 cubed, or 2 to the power of 3, is equal to 8. And all a log is, or a logarithm, is writing this in a different way. So the way we actually write this is equivalent. We've got log to base 2, 8 is equal to 3. And what we're saying here is that wherever you see the word log, just think index. So what we're trying to say in this second statement here is that what's the index in base 2 to get to 8, i.e. how do I get from 2 to 8, what do I have to do? What's the index? So here we can see the index here is 3, it's a cube, and all we're saying is that is the answer. This means that we can write a general definition of a log in the following way. We can say that a to the power of y is equal to x, and that's also equivalent to the fact that log base a x is equal to y. So just give you an example here. We're going to evaluate a log and see if we can get an answer out. So I'm going to evaluate log base 8 to 32. And what that basically means, as said before, is if we look at the index from base 8, how do we get the answer 32? So the first thing we do is we write log base 8 32 is equal to something, and we're going to call that x. And this something, the x, is the index that we have to raise 8 to the power of that x equal to 32. So what we do is we then rewrite it, and we can say that 8 to the power of the index is equal to 32. Once we have that now, we're basically going to be using our index laws, or the way that we solve the index equations, which is on one of my previous videos. So the first thing we need to do here is to get the same base, and we should be quite happy that 8 is 2 to the power of 3 multiplied by x, and that's now, or to the power of x even, and that's now equal to 32 is 2 to the power of 5. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Using our index laws, if we have a bracket, then we multiply the indexes together, so we end up with 2 by 3x is equal to 2 to the power of 5. Once we have the bases the same on the left and the right, so here what we have is we have 2 here and 2 here, we can now drop the bases, because all we're interested in is that the indexes are equal to each other. So we can now drop the base. If we do that, we end up with 3x is equal to 5. We now have a very basic linear equation to solve, and x is equal to 5 over 3. Okay, I'm going to do another example just so that you get to see this again. And we're going to work out, instead of log 8 32, let's do log base 3 81. Again, what we have here is we're saying, how do we get from the base of 3 to the power of something is equal to 81. So let's rewrite that. Log base 3 81 is equal to x. And again, 3 to the power of something is equal to 81. So we can now write that in index form. So 3 to the power of something is equal to 81. Okay, we need them all to be in the same base. So what we need to do is we need to try and get 81 into base 3. So 3 to the x, well, 81 is in fact 3 to the power of 4. Because you've got 3 times 3 is 9, times 3 is 27, and 27 times 3 is 81. Now that the bases are the same, the base number of 3 here, what we can do is we can drop the base and just put the indexes equal to each other, and this one's nice and straightforward. We end up with x is equal to 4. Okay, we'll try one more. We'll go log 4. So log base 4, 1 over 8. So this time we have a fraction. Again, we're going to do exactly the same thing. We know we were trying to find out what is the index we're going to use to get from base 4 to the answer 1 over 8. So we set it up again. Log base 4, 1 over 8 is equal to some index. So 4 to the power of something is equal to 1 over 8. So we can write that down. 4 to the power of something is equal to 1 over 8. And again, what we now have to do is use our index laws to solve this index equation. We need the same base, and you can see what we have is we have 4 to the x is equal to 1 over 8. The bases are not the same, so we're going to try and get everything in the same base, and the base that we're going to use is base 2. So we can write 4 as 2 squared by x, and we can write 1 over 8 as 1 over 2 cubed. Now, the left-hand side is not a problem. I can just multiply the indexes together as per the rules. So we have 2 to the power of 2x. But on the right-hand side here, what I have is I have a fraction. So I now need to use my index law. 2 to the power of minus a is equal to 1 over 2 to the a. So in this case, what I have is I'm using that backwards. So 1 over 2 cubed is equal to 2 to the minus 3. Now that they've got the bases the same, all I have to do is drop the base and equate the indexes on the top. So I now have 2x is equal to negative 3, and x is equal to negative 3 over 2.